In this new section, we look at polynomials with real coefficients, and I highlight the words real coefficients here. Now this means we are looking at examples like this. We are looking at maybe z squared plus 3z plus 2, where all the coefficients are all real numbers. Now what we are not looking at are examples like this, z squared plus iz plus 1. Now these are equations where some of the coefficients, for example this one, is a imaginary number. It is not real. Alright? So we are not looking at this. Now before we proceed, I want you to make some amendments to your notes. Now the fx that you see here and you see here, now please change them to fz. Okay, done? Now suppose we have fz, and this is a polynomial with real coefficients. Then a rule that you can apply straight away is this. If z is a root, and if z is equal to a plus ib, and is a root of the equation fz equals to 0, then its complex conjugate, okay, is also going to be a root of the equation. Now what this means is complex roots will always occur in conjugate pairs. Now let's put what we have just learned in example 10. In example 10, we want to obtain an equation, a quadratic equation with 1 minus I root 3 as a root. Now if you recall, we say that if z is going to be a root of fz equals to 0, then z star or z conjugate is also going to be a root. That's why if I say that my 1 minus I root 3 is a root, then the other root is going to be its conjugate, which is 1 plus I root 3. Now there is only one other root here because this equation that I want is quadratic. So how do I form quadratic equations when I know the roots? Remember, x minus z, okay, where z is the root, multiplied by x minus z conjugate equals to 0 will be the equation I need. Alright, so that's why I can write this down straight away. And all that remains now is to multiply them out term by term. And quite easily, I'm sure you can see that this will be your answer. Okay? Now there's an alternative method that you may have learned when you're learning Amax last time. So the alternative method is to use this relation. If alpha, beta are roots of a quadratic equation, then you know that the equation can be formed, okay, using this rule: x squared minus the sum of roots x plus the product of roots equals to 0. So you can use the formula here to straight away give you your answer. You add the sum of the roots, which is 2, and you take the products of the two roots, which is 4, and then you can straight away sub into this equation to give you this answer. Both methods are fine. It is your preference.